Good morning, all of you. I welcome you all once again in this lecture series on engineering hydrology. This is the second lecture. In the previous lecture, we have discussed about the fundamentals of hydrologic cycle, the process of hydrologic cycle. Then we had seen various components of the hydrologic cycle, and in those components, one you can say that is the precipitation. The important thing is the precipitation. So if I see the things again, hydrologic cycle, in that first component you can say that was precipitation or rainfall. If you look at any catchment area, I'm drawing over here, this is the catchment area. There will be some river, major or minor river flowing in this area. Okay, this is the river. There may be many tributaries joining this river. So for this catchment area, you will be saying precipitation or rainfall is as a input to the catchment area. Output is runoff. That is, suppose you have some discharge or runoff stations over here, and you are collecting or you are measuring the discharge data in the river. Then discharge or runoff is the output, and losses are, you can say, interception, dead storage or depression storage, infiltration and evaporation, evapotranspiration. All these will come in the category of losses. So input minus losses, you can simply say input rainfall minus abstractions is equal to runoff. Okay. So in the last class, we were talking about the runoff. In that, we have seen the mechanism of rainfall, different types of different forms of rainfall, how we can measure the rainfall data. After that, whatever data you will be having, so for that we were looking, when we are analyzing the data, we have past year records, sometimes 30-year, 40-year, 100-year record of the rainfall data. So whenever you have any data, first you need to check whether is there any missing rainfall value. Then you need to fill that missing rainfall value, and after that, what you will be doing, you will be checking the consistency of the rainfall data. So till there, till that point, we have discussed the things. Another thing that is that is necessary in this catchment area, you will be having various rain gauge stations. I think someone else is controlling the white screen. This whiteboard screen. Please do not use your mics. You just need to listen the things. Okay. So this is the catchment area. You will be having various rain gauge stations. Okay. You can say, suppose one station is over here, another 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 station is over here. So you have 5, 10, 20. That will also depend on the size of the catchment area. If larger catchment area, you will be having more number of rain gauge stations. Whatever data you are getting from the rain gauge stations, that will be the point rainfall data. You are getting the rainfall value at a particular point. But most of the time we work on the average value for this catchment area. So how we can do the aerial averaging of rainfall value. from that point value, how you can find out the aerial averaging for one value that will be representing for the whole catchment area. So there are many methods for that. One thing that you can simply see, you have 5 rain gauge stations, suppose. So you can take the mean of that. You can take the mean of all these 5 stations. Okay, I can write over here. Can you see this MS Word sheet? Just reply for that. Can you see the MS Word sheet at this time? I'm writing one thing that you can go with
No, sir.
for aerial averaging. One is averaging you can take. For that, what you will do, you will simply write the formula. Uh, or I can write, suppose this is P mean will be equal to summation of Pi multiplied by Ai divided by total area, and I is equal to 1 to n. Can you see this whiteboard or not? Please reply for this. How I can get your reply? Can I see? Can you please?
Sir, we can't see MS Word sheet.
Okay. You are not able to see the MS Word sheet. What should I do for that? I should go, because initially you were able to see that. I think you should be able to see this MS Word sheet. Is it? Can you see? Whatever I'm writing in MS Word sheet?
No, sir.
No. Then what should I do?
Sir, try to stop share and then start sharing again.
Okay. Stop sharing. And now if I say present, no, window, this is MS Word. Can you see now?
Yes, sir.
Okay. So this is just aerial averaging. Another method that you can go for that, because what will be the problem in just averaging when you are taking the averaging, then now can you see this whiteboard? Can you see this whiteboard?
Yes, sir.
Okay.
Yes,
So
sir.
what may be the problem when you are doing just averaging? So it is not actually happening, because these rain gauge stations, it is not necessary they are uniformly distributed over the whole catchment area, because it will be covering some area, it will be covering some area, it will also be representing some area. So it is not necessary they are uniformly distributed. So what we do, up to how much area they are contributing, for that we go for, again I'm writing in the MS Word sheet. If you are able to see, then just say yes or not. It's in polygon method. Can you see this whiteboard? Sorry, can
Yes,
you
sir.
see
Yes,
this
sir.
MS Word sheet?
Yes,
Yes,
MS
sir.
sir.
Word
Yes,
sheet.
sir.
Okay.
Yes, sir. Yes,
It's
sir.
in polygon method. So in that, what we will be doing, whatever, suppose If I someone else has written so much in the board. Okay, when you have, suppose this is the catchment area, okay, and you have one rain gauge station here, one here, and another here. So three stations are there. What I will do in Thyssen polygon method, I will join simply these three like this and draw the perpendicular bisector over here, then perpendicular bisector over here, and perpendicular bisector here. So this is suppose one, so it will be
सर
contributing
स्क्रीन
at
ब्लैक
this.
हो गई.
स्क्रीन ब्लैक हो गई तो अगेन आई नीड टू, कैन यू सी?
No,
नो
sir.
सर.
Okay, now you will be able to see the whiteboard. Can you see this whiteboard?
No, sir.
नो सर, स्टिल ब्लैक.
It is still black. Now you will be able to see, is it?
No, sir.
No. What
No,
is?
sir.
Okay, if I'm not writing anything on the whiteboard, if I am just simply using this, I can also use, can you see this MS Word or not?
Yes, sir.
Okay,
Yes, sir.
so we will be doing all the things in
Okay.
MS Word. We will not be going to whiteboard because whiteboard uh, uh, is always asking for some permission, and all the time we need to save it. So I can simply, but it is blinking, is it? So this was the. Oh. I think problem is in using the MS Word sheet. It is not very easy. It is also blinking. Then
Sir, you can use paint.
I can use which?
Paint, sir.
Paint. MS
Okay,
Paint.
MS Paint. But I cannot write formula in that. So I was using this thing. Okay, I will be going with the whiteboard and I will not be using MS Word because when I am shifting from one screen to another screen, then it is creating the problem.
Yes, sir.
Okay, so now again I'm sharing with you this thing, this whiteboard. So I think you will be able to see the whiteboard. Again, you might be asking for the permission. You need to click something. You can see that. Can you see this whiteboard?
Yes, sir.
Okay. All are able to. What are you saying? Okay. So when this is A1, this is A2 area, I can simply write like this, and this is A3 area contributed by this third rain gauge station. You can simply write the formula like P bar, this is mean precipitation, will be equal to and summation of I equal to 1 to m, whatever.
Sir, we can't see the whiteboard. Sorry to disturb, sir, but we can't see the whiteboard.
Okay. Now I will not be shifting from one screen to another, always be on the whiteboard. So that's why the problem should not be there. What I can do, if you are not able to see this, I can now again. Are you able to see the whiteboard now? Are you able to see the whiteboard now?
No, sir, we can't.
Yes,
It's
sir.
still presenting you right now.
I think you should be able to see, because it is showing that you are, or two students are there, Sushil Moria and Sumit Pandey. They can see this whiteboard. Hmm. Now we will not be shifting from this whiteboard, always be on the whiteboard. So that's why it will not create problem. The problem was main due to main problem was when we are going to another screen. So again, it is creating the problem. Now you will be able to see the whiteboard. Is yes or no? Till now that I can also charge.
Yes, sir. Yes, sir.
Can you see?
Yes, sir.
Please tell me if you can see it.
Yes, sir. We can see.
You can see the whiteboard. So we are going to start. Aya, can you see? Where are the people? How many people are there? Satyank, can you see?
Yes,
Hmm?
sir.
No, sir.
Uh, should be. It is showing. Still, you are not able to see. Five or six pupils can see this. Six people are there, or other people may not be able to see. I think it will be asking for some permission from your side. When I am sending the message for whiteboard, should we start now? Please reply again. Can you see the whiteboard?
Sir, there is a screen of jam.
There is a screen. In that whiteboard is there. If I write anything, can you see that?
No, sir, there is no Microsoft Excel.
No, no. I'm not asking for Microsoft Excel. This screen is open, but I am closing this. I will not be using that. I will only be using this whiteboard. So can you see this whiteboard?
Yes, sir. Yes, sir. We
Okay,
can see this whiteboard.
okay. Thank you.
Sir, for those who can't see, they need to go to the link which is there in the chat box, and from that link they can download
Yeah.
Jamboard, and then they'll see.
Yeah.
They don't know this, sir,
Yeah.
so they should.
Please do the same thing, because when I am creating the Jamboard, it is sending some link. You can go to the chat box.
खुशबू वहां से चैट बॉक्स से क्लिक करके, या जो भी जिनको भी नहीं दिख रहा है वो सब वहां से कर सकते हैं, फिर दिखेगा व्हाइट बोर्ड.
हाँ, कर
जैम
रहे
बोर्ड ऐप इंस्टॉल करने के बाद सही हो जाएगा, वो दिखने लगेगा स्क्रीन.
Okay.
So now we can see.
Yeah. Okay. Thank you. So we were talking about the aerial
सर एक बार
averaging.
लिंक फिर से शेयर कर दीजिए.
अभी भी सारे लोग नहीं देख पा रहे होंगे, क्योंकि इसमें 7-8 लोगों का दिखा रहा है. I think we should start now. We can see later on. So we were talking about real averaging. So first you can go simply averaging. If this is the catchment area, you have few rain gauge stations. Find out one value that will be representing the whole catchment area. So you can just take the mean of that. How you can take the average, you know already the formula. Next method that you can go, because what may be the problem when you are going for simple averaging, it is not necessary these rain gauge stations are uniformly distributed over the entire catchment area. So one may be contributing for larger area, another may be contributing for a smaller area. In that case, we go for Thyssen polygon method. We also consider for the area how much any rain gauge station is contributing to how much area. So for that we join all the rain gauge stations like that. Then we draw the perpendicular bisector over here, perpendicular bisector over here, and perpendicular bisector over here. So now this is the one, this is first rain gauge station, and this will be the area covered by this rain gauge station. So we will also account for this. This happens in Thyssen polygon method. Again, this Thyssen polygon method is very good for plain terrain, but if you are in working in hilly areas, so it is not good to use, because in hilly areas, I can also write this Thyssen polygon is good for hilly. Sorry, plain terrain. But if you are in hilly areas, because in hilly areas in mountains, you will get wide variation in the rainfall values. So you also need to take account for I discuss here another method that is also called isohydral method. You can go the correct spelling of this, whether it is or something else is there. You can check that. isohydral method. We use it. This is used for hilly areas. Right? What we do in that, first you should also understand what are these isohyds. Isohyds. Okay, you can simply say these are the lines or curves joining or the curves of equal rainfall value. Okay. As you also define, many terms are there. Like isobels are there. You may have heard about this. Isobars are there. Similarly, you also define contours. Okay. Contours are the lines or curves of equal elevation. Isobars, you can say, these are the lines or curves of equal atmospheric pressure. And isobels are the lines or curves joining the points of equal velocity. Similarly, isohyds are there. If I consider some hilly area is there, suppose this is, I should, where is eraser? When we are using this eraser, we are missing that duster. It is easy. It is not easy to remove by using this eraser because this is of very small size. This should make it larger. Okay. So I can draw the things. First, I should remove this also. This is the hilly terrain, suppose. So what I will do, I will draw the isohyds of different rainfall values. These are the isohyds. These are the planes or curves. Okay, lines or curves. So for it will be having, suppose, the value P naught. This is P1, and area in the middle of this is, suppose, A1. This is A2 area. This is P2. So similarly, you will be having the scenario. In that, what we do when you have to find out the value of P bar, I can go simply P isohyde values Pi minus 1 plus Pi divided by 2. So this is the rainfall value for this area multiplied by AI, and will take the summation of that and divide by total area. So in this way, you can easily find out the isohydral method. You can find out the aerial averaging or average value for the whole catchment area by using the isohyds. Next, we come to, we also need to plot when we will be doing the analysis for rainfall data. We will be looking for different types of plots are needed. Okay. So first type of plots generally required, they are called depth duration or depth area curve. Okay. Depth area curve, and you can also add in this duration curve. So how they are plotted or what is the importance of them? Suppose any storm occurs due to a storm, due to storm of 5 hours. 5-hour storm is occurring. What is the meaning of that? Suppose rainfall is occurring over some area for 5 hours. Okay. So what will be happening? So this is the area covered. This is not the catchment area. This is the area covered by this rainfall storm. And this is occurring for 5 hours and it has covered this much of area. So wherever there will be the storm, we also define one term that is called the center of the storm. Center of the storm, then storm will be there, and center of a storm is that point where maximum rainfall intensity is there. It is the point wherever is the rainfall intensity maximum, or in other word you can say wherever it is the maximum rainfall intensity, you will be having some rain gauge stations over in this region. So wherever it is the maximum rainfall intensity, there you can say it is the center of the storm. At the same time, another question can also rise in your mind that it is not necessary wherever is the center of the storm, at that point rain gauge station may also be there. It is not necessary because you have already installed the rain gauge stations. You don't know where will be the center of the storm. Okay. So what we do, we say if it is in the region of 25 kilometer square area, okay, if in the region of that much area, if suppose this is the center of a storm and any rain gauge station is within 25 kilometer square area, then you will be considering that much of value is there. Okay. So suppose this is the center of the storm. As you move away from this center of the storm, then this rainfall value will be decreasing. So you have for that some empirical relations, how this value will be changing with respect to, suppose this is area and this is rainfall depth. So depth area curve, and for different duration you will get the curves like that. There are also few empirical equations. You can go through that. You can see the book, and whatever are the equations, you can see that. I'm not writing the equation over here. Something like this is P at covering to this much of area. Suppose this is area A covering to this much area. You can simply write P naught is the center value. The center of storm is there. It is the value at that point. E to the power minus some constants are there. I'm not writing that. You can go through that. Another type of curve that are required, they are called depth duration and or maximum depth duration and maximum intensity duration curve. They are very, very important when we are analyzing the past year records. Whenever you will be working on the rainfall data, most of the time you will be working with the daily rainfall data. Suppose you have to do the rainfall forecasting. Then in that situation, you will not be interested in knowing whatever is the maximum value or minimum value. You will be looking the whole rainfall value, and based on that you will be predicting the things in the future. But many times whenever you will be designing any structures or many things, you will be interested in maximum value. Many times it is required maximum value or minimum value. I can write here. So two different types of curve: maximum intensity duration curve. Another is maximum depth duration curve. Okay. These two types of curves are there. How will be the maximum intensity? Duration means like 1 hour duration, 2 hour duration, 5 hour duration. I will not be again discussing about this. You can solve few numerical problems for how we plot the maximum intensity duration curve and how they look like. One thing is added with this. Most of the time you will see it is already not complete thing. And most of the time you will also be working with frequency analysis is also there. Maximum intensity duration frequency curves and maximum depth duration frequency curves. So we deal with, and for designing or for any structures or hydraulic structures, we go in the detail of that. I'm not discussing about this frequency analysis at this time because you know, we are not having the very large time. Then we will be talking about the flood estimation and flood modeling. Then we go in the detail of this frequency analysis, because whenever you are talking about the floods and droughts, they are the extreme value events. Extreme value events. So during the design of the floods or estimation of the flood value, we will be talking about the frequency analysis in detail and risk analysis in detail. So then we will see the things in the detail. At this time I'm skipping for this. Okay, we will be talking about, because it need to be discussed, otherwise you will be facing some problem in understanding the frequency analysis. This is quite important. Next, so this was all about the precipitation. Now we will be talking about the abstractions. If I'm talking about the abstractions, what are the different types of abstractions? I can go with interception. Okay. Another is dead storage or depression storage. Another you can say evaporation, as well as evapotranspiration. Okay. Next is infiltration. When you are working in the in rainfall, or you are working in for rainfall runoff process, you will say all these are the losses, because finally your focus is on runoff. How much runoff is generated from the rainfall, you will be looking for that. In the last class, we had already discussed about the interception and depression storage. Interception is that part of precipitation or rainfall which is trapped by plant trees, vegetations, and other structures, because a lot of amount of water is also trapped by building roofs, structures roofs. So that comes in the category of interception. Depression storage is that part of precipitation which is used in filling small uneven portion, or small pits, ponds are there. So combinedly, we also study these two combinedly, because it is not easy to find out these things. Again, they will depend on the catchment area, if it is, whether it is residential area or whether it is forest. So things will depend on that, and combinedly these two, we use the one term that is called initial loss. Initial loss. Okay, it is not easy to use using this cursor. Initial loss is there, and there are also few empirical equations for obtaining the value of interception, depression storage, and combinedly the initial loss. So you can go through that. Simple 1 or 2 equations will be there. You can see in the book. Next, we see the process of evaporation and evapotranspiration in detail. How first we talk about the phenomena of this evaporation in detail. I write here. First, we are talking about the evaporation, because whenever any water body is there, suppose there's some reservoir is there, or any river is there, you will be talking about the evaporation. It is not about the evapotranspiration. Evapotranspiration will come into the picture when you are talking about the vegetations, you are talking about the plants. Okay. So now we are looking for evaporation. Okay. Already you are also familiar with the process of evaporation, but I discuss it something with the just basic things. Suppose I have some vessel over here and butter is filled in this. Okay, butter is, or ice is there. Suppose ice at minus 10 degrees centigrade is there, and if I just plot, this is temperature. Okay, I'm talking in degree centigrade, and this is about the internal energy. I for internal, E for energy. Okay, this may be in joule or calorie per gram, like that. So this is internal energy, this is temperature. If I start from minus 10 degrees centigrade, okay, at minus 10 degrees centigrade, I'm talking about the pure water. So at minus 10 degrees centigrade, it will be in the state of ice. Okay, and it will be having some internal energy. Okay, as I provide the heat to this vessel, okay, as I provide the heat energy, there will be rise in the temperature of this ice, and it will be going like that, and up to 0 degree centigrade. This is 0 degree centigrade. Okay, so it will be at 0 degree centigrade, it will be ice, and there will be rise in the temperature. Initially it was minus 10 degrees centigrade. At 0 degree for pure water, this is also the fusion point. Fusion point, FP. Okay, it is not easy to write fusion point, so that's why I'm writing FP. What will happen? It will be asking for latent heat of fusion. It should go straight. It should go like this. So it will be requiring some latent of fusion, and there will be change in the state. It will be converted from ice to water. So now it is liquid water, it was ice. So this is latent heat of fusion. Basically, we define two different types of heat. One is called sensible heat, and another is called sensible heat. Okay, I can use this thing. Another is called latent heat. Okay. Sensible heat is directly proportional to temperature. If you are the part of heat is used in as a sensible heat, it will increase the temperature. Latent heat, this is basically related to change in the state. It is coming from solid to liquid, then it will be requiring for some latent heat, and then it will be increasing the temperature. Okay, now it is increasing the temperature, and when it is reaching to 100 degrees centigrade, then you will say this is the boiling point for water, and at that time it will be asking for latent heat of vaporization, and then it is converted into the water vapors, and there will be increase in the temperature of water vapors. So this is the whole phenomena takes place. Okay, if I simply ask one question, what is the difference between evaporation and boiling, you will just say boiling takes place at boiling point, but evaporation can take place at any temperature. Even the temperature is 0 degree centigrade, 1 degree centigrade, evaporation can take place. Okay, related to this, I just come to the main thing, because we will be talking about the water bodies here. So some lake or water body is there. Okay, this is the water body, this is the free surface of water. So generally the molecules which are at the surface, you have studied about the fluid property of surface tension, so you know better the phenomena of surface tension. The particles which are at the surface, they are having extra tension. So even if they are getting very small of heat energy due to sunlight, or anyway they are getting some heat energy, they are very easily able to escape from this free surface. Okay, whatever is the temperature, suppose this is 20 degrees centigrade temperature, then also they will be easy to escape from the, and these are converted into the water vapors, and these will be collected, these vapors will be collected over here, and this will be called as the zone of evaporation, right? Whatever is, if you increase the temperature, more number of uh, water more amount of water will be converted into the vapors. So as you increase the temperature, this value, this size of zone of evaporation, that will be increasing. So this will be happening. What actually happens at any temperature, suppose 20 degrees centigrade, in the starting, the rate of evaporation is very high. Okay, that will be high because initially this space is empty, but so many water vapors are collected over here. At the same time, the condensation will also start. So we also define here one equilibrium state. What is the meaning of that? Initially, if rate of evaporation is very high, but when these water vapors are collected over here, they are colliding with each other, and there is cooling of these water vapors, so they are getting condensed. So processes are going on simultaneously: evaporation and rate of evaporation and rate of condensation. Okay, so when it becomes in the equilibrium state, at that time you will define one term that is called saturation vapor pressure. What is the vapor pressure? You will simply say vapors are collected over here, so pressure exerted by the water vapors, that will be the vapor pressure. Saturation, the things have become saturated. If you again increase the temperature, then there will be rate of evaporation will be increased. I can also write one formula over here. It is not easy to write the formula because I can write if saturation vapor pressure is denoted by EW. So at any temperature, you can say it is something like 611. You can also see from the book or any net, Google, e to the power 17.27. This point is there, multiplied by T. This T is in degree centigrade. 237 point, this is empirical equation, 0.3, this is point, plus T in degree centigrade, this is, and this will be in Pascal. You know the atmospheric pressure is, what is the value of atmospheric pressure? You already know, 1.01 into 10 to the power 5. So that is the value of Pascal, atmospheric pressure. So at any temperature, whether it is 20 degrees centigrade, you can find out how much evaporation, saturation vapor pressure will be there. Okay. You can also put the T equal to 100. If you put T equal to 100, this EW will become equal to PATM, atmospheric pressure. So that's why we define the boiling point. The boiling point is that temperature at which the saturation vapor pressure becomes equal to the atmospheric pressure. Okay. Okay. This was all about the process of evaporation in this way. Now you will be dealing with two different types of vapor pressure. One is saturation vapor pressure, and another you can say actual vapor pressure. Okay, saturation vapor pressure is, you can denote it by EW, and this is EA. So whatever is the difference between this, if this EA is less than EW, then in that condition the evaporation will take place. If EA is equal to EW, in that condition no evaporation will take place. Okay. If EA is more than EW, then in that condition the condensation will take place. Okay. What are the various factors affecting the rate of evaporation? One factor that you can say, the difference between EW and EA, whatever is the difference, if the difference is large, more evaporation will be taking place. Next, you can say wind speed. Wind speed. It also plays very, this is wind speed. Wind speed. Okay, this also plays very much important role in the rate of evaporation. It also increases the rate of evaporation because these water vapors are collected over in this zone of evaporation. So this wind speed helps in removing these water vapors from the zone of evaporation and increases the chances for, increases the rate of evaporation. This will be making empty this zone and it will increasing. So you can say the rate of evaporation will be some function of, it will also be depending on some function of velocity and EW minus EA. This rate of evaporation will also depend on the size of the body. If body is shallow, then there will be more evaporation. If body is deep, water body is deep, then there will be less evaporation. Similarly, people also, because in reservoir a huge amount of water is collected, or in the rivers water is flowing, but in reservoirs water is almost steady and huge amount of water is there, it is stored. If we are not reducing the rate of evaporation, it will be very large amount may also be evaporated. So people also use many types of chemicals for reducing the rate of evaporation. You can go through that which chemicals are used for increasing or for reducing the rate of actually the chemicals form a chemical film over the water body or surface of the water body. Okay, so this was about the process of the evaporation. This is the phenomena of evaporation. Now, how you can measure the data? For that, we use different types of evaporation. There are different types of evaporation fan which are used for measurement. Again, the concept is there. They will be like rain gauge stations. They will be installed in few kilometers area. Again, they will be having some specifications, some guidelines for that. In how many kilometers they will be installed. What should be the number of evaporation fan. So some water will be stored there and how much has been reduced. So based on that, they will be giving you the reading. So again, there are on the basis of American standard, Indian standard, you can go through that. Basically, there are 4 types of evaporation fan. You can go through that. I will not be discussing that in this class. Next is, so this was about the evaporation fan. Next is, there are also few empirical and theoretical equations. You can also go through that. Empirical Mayer's formula is there and Rover's formula is there. You can go through that. These are the simple formulas. You just have to put the values and you can find out the rate of evaporation. That will be in millimeter per day. You can find out that thing. Similarly, there are also many theoretical equations. Basically, three equations are there. One is related to energy budget, water budget, and mass transfer. Turbulent mass transfer theory is there. So turbulent mass transfer theory is not in your syllabus, but water budget and uh, energy budget, that you should go through that. So simple derivation is there. You can go through that. So this was all about the evaporation. Next process is evapotranspiration. Okay. Next process is transpiration. I simply talk about the process of this time transpiration, because it is not easy to say whether it comes in the when you are talking about the plants, whether it will come in the category of evaporation or whether it will come in the category of transpiration. So you already know the process of transpiration. Let's say, for example, if you are talking about this is the earth's surface and trees are over here. So if rainfall occurs and it is over the plant leaves and then it is evaporated, this will come in the category of evaporation. Okay. What is the transpiration? If this was the water table, above the water table you are saying this is the unsaturated zone, and in this unsaturated zone, whatever is the soil water zone, this is very important for the plants. Okay, soil water zone, or generally in unsaturated zone, mainly we talk about the soil water zone, because intermediate means nothing. The intermediate thing is there, and the height of the capillary rise is usually very small in case of sandy soil. And so when we are looking all this, we generally neglect this capillary action, but we study that, but generally that is not of very much practical importance. Capillary. So we are talking about the soil water zone. This is soil water zone. Okay. So plants will be extracting water from this zone through their roots, and through its trunk it is reaching to their leaves. They are cooking the food, and finally that water is evaporated. So that will come into the category of transpiration. If I simply ask one question, what is the difference between evaporation and transpiration? I will say evaporation, you can better understand or better get the idea. Evaporation can take place even in day and during day and night. In the night also evaporation can take place, but transpiration can take place only during the daytime, because plants cook their food during the daytime. Okay, transpiration can take place only during the daytime. Okay. To better understand this process of transpiration and evapotranspiration, combinedly we use this term, and this is we also write ET. This is for evapotranspiration. Okay. Just go in the detail of this evapotranspiration process, then we will see how we can measure the data. So we have, this is the earth surface. Okay. So when rainfall is occurring over here, some amount of water is going into this region. This is, again I will be saying, this is water table, and this is unsaturated zone or soil water zone, simply I say. Okay, this is unsaturated zone. Right. So water is getting infiltrated, or water is going into this ground, below the ground level. So this is unsaturated zone. So what will happen first? Whatever amount of water is going into the ground, first it will be used in satisfying first it will be used in increasing the moisture of this unsaturated zone. We also define one term that is called field capacity, be denoted by capital F. Okay, so field capacity, what is this field capacity? I can simply write, what is this field capacity? I can write, this is the maximum amount of moisture that the soil water zone, I simply write that the soil water zone can retain against gravity. Okay. Maximum amount of moisture that the soil water zone can retain against gravity. So whatever amount of water is going into this ground, up to the field capacity, it will be retained in this zone, and after that it will be contributing to the groundwater. It will be increasing the water table and it will be contributing. So whatever amount of water is going into the ground, first it will be increasing the moisture content up to the field capacity, and when this need of this unsaturated zone is satisfied, after that it will be going into the ground, going for contributing the groundwater. Okay, this is actually happening. We also define, so that's why people also say when you are irrigating the land, you are providing so much of water over the land. So so if you are thinking for the purpose of irrigation engineering, so up to the field capacity, that much of water will be retained in this, otherwise it will be increasing the groundwater. We also define one term that is called permanent building point. Okay, PWP, permanent building point. If the soil moisture or moisture in this zone, in this unsaturated zone or soil water zone, is less than PWP, less than permanent building point, then the plants will not be able to survive. So for if you want the plants should survive, then at least this much of amount of moisture should be available in this zone, in this soil water zone. So this is the requirement. At least the soil moisture up to this permanent building point should be there. Okay. If I simply draw about the moisture in the soil, if I start from 0, the maximum amount of water that can be retained in the soil, that is eta, that will be equal to the porosity, whatever is the porosity of the soil, so that much of water can be stored there. Okay, one is called hygroscopic water. Okay, so actually what happens when water is available in the soil pores, so there is a huge amount of water that is between the pores, and a lot of water is also, and some amount of water is also stuck to the particles boundary, soil particles boundary, so it is not easy to remove. So that is basically called the chemical bonding between the water and soil particle is very good bonding, so it is not easy to remove that water. So that is whatever you are doing, but you cannot remove this water. If you go up to some level, you will get permanent building point. Okay, and this will be somewhere this is the field capacity F. So when you are irrigating the land or landfall is occurring, it will be retained in the soil of soil water zone up to field capacity, and the remaining will be going to contribute to the groundwater. So whenever you will be talking about the evapotranspiration, then we use two different terms. One is called potential evapotranspiration and one is called actual evapotranspiration. Okay, two terms are there, potential and actual evapotranspiration. Actual means whatever amount of moisture is available there in this soil water zone. So based on that, whatever will be the evapotranspiration, it will come into the category of actual evapor. Potential means maximum. If water is in this zone is available up to the limit of the field capacity or more than that, whatever is there. So in that situation, you will be saying, the maximum amount of evapotranspiration will take place. So this was all about the process of evapotranspiration. How you can measure the evapotranspiration? For that, the devices which are used for that, lysimeters, sorry. You can use the lysimeters. How they work, you can go through that. How these lysimeters work, you can go through that. And there are also few empirical and semi-empirical equations for measuring evapotranspiration. One is Blaney-Cradle equation. I'm not sure about the spelling. You can see that Blaney-Cradle formula. Another is Hornbeck equation. And the most important one is Penman equation. Okay. So these empirical and semi-empirical equations are there. Similarly, when the empirical equations are having very complex formula, in this you will also get some complex formula is there. So they will be used for project work, but no one will be asking just for that, and no one will also be desiring that you are cramming the formula for your exam. It is not easy to keep in your mind whatever is the equation is there. Many components are there in the equation, but at least you should know how to use these equation. Penman equation, Penman, I think double N will be there or single N is there, so you can go through that. Okay, this was all about the evapotranspiration and evaporation. Next important abstraction, or last, the most important, is the infiltration. Okay, now we are talking about the infiltration. Okay, infiltration. What is this infiltration? You can simply call the movement of surface water below the ground surface or ground level is called infiltration. Okay, movement of surface water below the, whether rainfall is occurring, it is going into the ground, it is going in below the ground, or whether surface water is there, or you have irrigated the land, it is going into the ground, then you will say that comes in the category of infiltration. Again, I will be saying the same thing. When whatever amount of water, you need to think for two things. Two things will be happening. Whatever amount of water is getting infiltrated below the ground level, first thing, what will be the assess of that? It will be increasing the moisture content of the soil water zone up to the field capacity, and after that it will be contributing to the groundwater. Okay, we also define few terms over here. I just write here field capacity. Okay, field capacity be denoted by FC. Small FC is there. Field capacity. Okay, so how you can define this thing? Because you also need to take care of this field capacity, when you are looking for this field capacity, we also define another term, the rate of, sorry, already we have discussed about the field capacity. This should be infiltration capacity. I'm sorry for that. Okay, infiltration capacity is there. So you can say this is the maximum amount of maximum rate of infiltration at any time. Okay, I can define this thing. I should write this thing, otherwise you will be confused. Maximum rate at which water can infiltrate at any time. Why I'm writing this at any time? Because initially, suppose the soil is dry and the rainfall is occurring. So when it was dry, in that situation, the rate of infiltration will be very large. As the time passes and soil is getting wet, then the rate of infiltration will also be reducing. Okay, so I'm talking about at any time. If I have to plot FC versus time, this is field capacity versus time as the rainfall occurs. So you can say this plot will be something like this. Okay, as the time passes, this field capacity is reducing. Initially, when the soil was dry, the field capacity was very large, but as the time passes on, the soil is becoming wet, or there is moisture in the soil water zone, or is unsaturated zone is increasing, then the field capacity will be reducing. You can also take just simple example, this just funny example. When you are eating the food, you are taking the food, when you are very hungry, then your capacity of taking the food will be very large, but as you are eating some food, and after that you will be your capacity will be reduced. Okay, next thing, if I'm relating it with the rainfall intensity, suppose I connect it with rainfall intensity. So you can see rainfall intensity I. Okay, if I say this FC is there, this is infiltration capacity. Okay, this is rainfall intensity, and I also use another term, the actual rate of infiltration. Actual rate or rate of infiltration, because capacity, whenever you see this term capacity, this will be telling about the maximum thing. Actual may be anything. Suppose I take one condition when this I is less than equal to FC. What will happen in that situation? If I is less than equal to FC, in that condition, whatever amount of rainfall is occurring over the catchment area, all the water, all the rainfall will be infiltrated, because this is less than FC. Capacity is very large, but amount of rainfall is less. So all the water will be infiltrated. Okay, in that situation. And if I consider another thing, I is greater than FC, then only there will be some excess amount of rainfall. Whatever in this situation, the actual rate of infiltration will be equal to FC, and there will be excess rainfall, which is not, that amount of water is not getting infiltrated, and that will be running over the surface as a surface flow. That will be resulting into the runoff. Okay, so this was the process about. In this situation also, if I break this, if I is less than FC, then in that situation you can say F will be equal to I, because FC is there, but water is not available. Whatever amount of rainfall will be occurring, so that will be F will be equal to I. If I is equal to FC, then you will be saying F will be equal to I or FC. All the things will be equal to FC, and in this situation you will be saying the rate of infiltration F will be equal to FC, and in this situation there will be excess rainfall. Okay. I can also draw a hydrograph over here. Okay. I can draw simple hydrograph over here. Suppose you have some hydrograph like this. Hydrograph means rainfall intensity I millimeter per hour with respect to time. This is simple hydrograph. HYETOGRAPH. Okay. So if you are considering the mainly loss due to the infiltration, then if I also consider some constant value of FC, or this is the loss due to infiltration. Okay. Loss due to infiltration. INFI. Okay. Then, and suppose, okay, you can better understand if I draw like this. This is the loss due to infiltration. Okay. Yeah, this is telling about the FC value, whatever is there. In this situation, you will be saying infiltration will be equal, the rate of infiltration will be equal to this I. Although field capacity is more, but the amount of water is not there, so whatever is available, it will be going into the ground. In this situation, you will be saying in this time period, this much of used for satisfying the infiltration need, loss due to infiltration, and this will be the excess rainfall. We also use another term that is called effective rainfall. That will be very much important when we will be looking for the runoff analysis in the next class. Effective rainfall or excess rainfall. Okay. When we are talking about the effective rainfall or excess rainfall, then this will be very, very important. Okay. So this was all about the process of infiltration. Next thing is how we can measure the infiltration data. For that, people use infiltrometer. Okay, different types of infiltrometers are used there. You can go through that. Next thing is there are also many empirical equations available. Horton's equation, Phillips equation, and Green-Amt equation. You can go through that and see how they are working. And they are simple formula. You can put the things, you will get how much. They will be telling you how much infiltration will take place. Next is very important in this section, that is called infiltration indices. From exam point of view also, this is very important. There are two. One is called phi index. It is not easy to make here. I am just writing phi index and W index. This phi index is just tells you idea about how much infiltration loss will be there. Okay. Suppose precipitation is occurring and you know the rainfall, and then it will give you some idea about the phi index. I'm not writing the actual formula that you need to see, because each limb is important. It is not you are adding something all, or it is not, because in this situation infiltration will be something else, in this situation infiltration will be something else, in this situation also infiltration capacity is there, but rate of infiltration will be something else. So if you know the rainfall, you know the runoff, then you can find out the phi value. You can solve one or two numericals, you will get the idea about this. W index, when you will be looking for this, it will also be account for initial losses. So you can say P minus R minus IA is equal to something. You will get some idea about W index. Otherwise formula you need to modify that. Okay. So this was, you please go through these two formulas and solve few problems related to these two. So this was all about the abstractions. First we have seen about the initial losses, then evapotranspiration and infiltration. So this was all about the first unit, whatever we have discussed in these two lectures. So this was related to first unit. In the next class we will be talking about runoff and hydrograph, and then unit hydrograph, synthetic hydrograph. We will be going in the detail of that. Third unit is related to flood estimation. So we will be discussing the things in the detail. How do we estimate the flood, and how we also do the flood forecasting. And at this time everyone is knowing that event of Chamoli. So how we are account for, there is one flood routing, one process is there, and how do we analyze for the flood, and how do we model the things related to floods. So we do. And unit 4 is related to groundwater hydrology, and unit 5 is mainly related to groundwater contaminant transport. So in these 7 or 8 lectures we will be able to see the main things related to this engineering hydrology course. So I think today we should stop here. That's it. And thank you all for being. Thank you everyone.
Thank you, sir.
Thank you, sir.
Thank you. Now we are closing this.
Thank you, sir.
Thank you, sir.
Thank you, sir.